Hello DevOps people, how are things? I'm Jochen, welcome to my stream. I'm going to continue my work on the DNS Cookbook for Chef today. But before we start, hello to everyone watching the stream. Feel free to pop up in the chat if you want to say hi, if you have any questions, if you have any feedback, if you'd like me to explain something, that's what I'm here for. That's why I do this live stream. And so let's make this a nice social thing as well. As you can see, I've just started a converge run for the cookbook, and let's run a verify right after that. And everything works. And the great thing is that I was able to answer all the questions that I had myself when I finished my previous live stream. And I'd like to take you through everything that I've built so far. So let's start with the use case. I wanted to build a DNS cookbook that you can use in Chef to not only start a DNS server, but also define the zone data that the DNS server needs. And that's why I've built a test recipe that does exactly that. It defines DNS records. For example, here's the record for www.example.com, and it defines an IP address for this name. Then here we have an MX record that defines the mail server for the zone, for the domain. So the first mail server for example.com is named mx1.example.com, and there's a second server that can receive email for this domain, and mx2 is its name. They have different preferences, which means people outside in the internet will first try to talk to mx1, and if mx1 doesn't work for some reason, they'll try mx2 because it has the next higher preference. Here we have a CNAME record that says blog.example.com is supposed to be the same address as www.example.com. And finally, I'm using the zone resource to say, okay, I'd like this zone, example.com, configured with the contact info at example.com. Then I'll do the same for another domain, not an example.com, with a single record, and then I'm using the zone resource again to actually deploy it. So what you can see is that everything is prefixed with the cookbook name, and I've chosen NSDX as the cookbook name. If you've attended previous live streams, you saw that I actually forked an existing cookbook, the NSD cookbook, that uses the DNS server that I selected myself, NSD. And I realized, okay, it does some basic installation things, but it does nothing with regard to these zone entries. So I built that part. And while building that, I realized, okay, what the NSD cookbook has is so rudimentary and sometimes not the way I would build things. And so I thought, okay, instead of trying to become a co-maintainer of the existing NSD cookbook, let's try to get this out first, because we at Freistyle IT have an actual use case for this cookbook. It's not an academic example. We really need this sooner than later. And maybe we can merge the cookbooks later, because I'd still prefer to have my cookbook here as the official NSD cookbook, because it has a lot more functionality, basically. But yeah, we'll see. For the time being, I'll simply use NSDX as the cookbook name, and I'll actually publish this later during the live stream as its own GitHub repository. And before I do that, I'll show you how I've implemented these chef resources. There are two resources that we have. It's the zone resource and the record resource. They are defined in the resources subdirectory of the cookbook. So let's take a look at the record first. This resource defines a number of properties, most of which are optional, because all that all the DNS records have in common is that they have a name and a zone and a type, and depending on the type they might have an IP address or a preference and an MX field or a CNAME field. So that depends on what kind of DNS record we're talking about. In any case, we have a create action for this resource, and what this action does, it is create a resource record object using a resource record factory class, and I'll show you that later. In the end, I get a resource record object based on the properties that were passed into this resource. Then I create a zone registry only to register to get a zone object from this registry. And then in the end I can add the record defined by this resource to the zone. I had a few circular dependencies that kind of broke my brain last time, and I decided to use this zone registry to get the zone that I need for adding the record. And what this zone registry does is there's either already an entry for this zone because there were previous records, or it's new, and in that case I get a new zone object. So I get an existing object or a new object. In any case, I get an object that I can then use to add the record. And the reason why I have this resource record factory here, I'll explain that in a minute. Actually, why not go directly into it? I split all the classes that I've been building up in different files. So here we have the resource record factory. No, let's take a look at the record object first. Because that'll make it easy to explain why I did what I did. So we have the resource record class. I've used my own namespace, the NSDX cookbook name, and I had defined a resource record. And what this thing does is basically have a method bind9 entry that will return a line of configuration or zone file content that defines a certain DNS record. So it's something like www IN A for a record and then the IP address. That would be one bind9 entry. And the main method was this bind9 entry method. That was the longest method of them all, because different DNS record types require different entry formats. So depending if it's an A record or an MX record or a CNAME record or something else, the format of this entry will change. And I had a case statement here that simply used the type field of the record I passed in and then decided which format to use. So if it's an A record, use the name and the IP address. If it's an MX record, use the name, the preference, and the MX field. If it's a CNAME record, use the name field and the then called real name field, which I've now renamed into CNAME, which makes more sense in a CNAME record. So what I realized was, I realized it after reading the recent article from Sandy Metz's blog, that these case statements almost always are pleas to split things up into different classes and then have a factory that does return the right type of object. So I said, okay, let's do OO the right way. And first, split up what I have into the actual classes that this use case calls for. So additional to the resource record class, I created new classes based on this resource record class. So the resource record class has become a base class that doesn't even implement bind9 entry. Instead, it will raise a not implemented error. And then create actual classes for the types of DNS records we can have. So now there's an A record class, which only has an IP address as an attribute on top of the 3 attribute every DNS entry has. So we'll simply take the IP address out of the record hash we pass in, and then we have a bind9 entry method that returns the exact zone file entry that an A record requires, namely name, IN, A, IP address. And then there's variations of this theme. So here we have the MX record class, which doesn't know what an IP address is, but it has a preference and an MX field. We'll take them out of the hash, and when bind9 entry gets called, we write out a line, name, IN, MX, preference, and the name of the mail exchanger. Same thing for the CNAME record. CNAME record knows the 3 common fields plus the CNAME field, which we take out of the hash. And when it's time to write a bind9 entry, it'll write it in the form name, IN, CNAME, and then the canonical name. And that's perfectly extendable and readable. And it's exactly as you would explain the concept of DNS entries to someone who doesn't know it. You'd say, okay, we have different resource records and they have different information, and therefore their zone entry will look different depending on what information and type we have. So I think this is how it's supposed to be. It might be a bit over-engineered for the use case we have, but I wanted this to be a good example of object-oriented design, and it might prove worthwhile later, because we'll have to extend this. We have more than these 3 or 4 record types. For example, the reason why I started building this cookbook was we'll need to automatically generate SPF records. that determine who is allowed to send email for a certain domain. So that's completely missing, and we will have to add that later. So that'll make explaining the factory easy, because somewhere we'll have to have that case statement, but this is the right place. It's a class that has a single class method, so we don't have to instantiate this class. We can call this method directly. We'll pass in the record data from the chef resource, and depending on its type, we create the right kind of object. Theoretically, I could even take the type and do a bit of string and constant magic to calculate the class name and replace this case statement with a single but much more magical statement that automatically creates the right instance, even if we add SPF as another type later. We won't have to touch this, but I didn't want to go that deep into Ruby meta programming to do this. I think this case statement is readable, and it's easy to understand what it does. So, when it's time to write the zone, which we do after defining all its records, we call the zone resource. It only has two properties at the moment. The zone has a name, which is the base domain name, and a contact. And what we do in the create action is register the zone. To be more precise, it shouldn't have to be registered at that point, because it should have records already, and so it should have been registered before. But we'll get the zone object back, and instead of adding another record, I'll simply write a template file, namely the zone file, and I'll simply pass in the zone's records into this template. And what the template does is go through the records and call their bind9 entry method. So the meaty part of this template is this short loop here. Go through every record, call its bind9 entry method, and you're done. That's the core business logic, and I had to implement the zone registry, which takes care of collecting all this data. So with every resource record resource and with every zone resource, we add more information to the collection, and that's how I implemented this collection. Zone registry has a constructor that gets the current node object as an argument in order to use its run state hash to temporarily store our information. So we initialize run state cookbook as a subhash, as an empty subhash if it doesn't yet exist. So run state nsdx, because that's the value of this constant. Run state nsdx will have all our domain and zone information. To be exact, it's a hash in itself with an entry for every zone, and the value to this key to the zone name is the zone object that has been built for this zone here with zone new, and that's all there is. So basically run state NSDX is simply a hash of zone objects, and these zone objects look like this. It's a simple constructor, and then in this constructor it initializes its records attribute as an empty array, and when we call add record, the records are simply appended to this array, and with records I can access this list of resource records. That's what happens in the template when we go through all the records of a certain zone. So that's it. If you'd like to use this cookbook as it is right now, you would simply build a recipe like this, include recipe NSDX default, that takes care of all the preparation stuff, creating directories, for example. Then you'd define your records, and when you're ready, the zone file for these records. And that's all you need to do. And then you'd call NSDX master to spin up a DNS master server. And I actually haven't taken a look at the slave recipe yet. That would install slave servers that always synchronize their information with a master server. That's something I'll have to do later. However, doing it this way is very, very, very verbose, because for every single line in the final zone file, you'll have to have 6 or 7 lines in your recipe, because it has names for every field, and instead of, for example, writing @INMX 20 mx2, you'll have to write NSDX record and some kind of title, name, @zone example.com, type mx is mx2, and preference 20. So it's 10 times probably or more the amount of characters you need. So writing the zone file by hand would be simpler, easier, maybe a bit more error prone, but from an efficiency standpoint, this is madness. So that's probably not how you'd define your resource records. How else would you do it? Let's ask the audience. Anyone familiar with Chef? How would you provide this cookbook with your zone information? No one? The class? Bueller? Bueller? Looks like you're not actually familiar with Chef, are you? Well, the answer is you'd define what's called a data bag. And this is simply a collection of hashes that contain information. On disk, every item in a data bag is a JSON file. And I've actually taken one of our production DataBack item files for the freistilbox.net domain. And that's how that looks like. It's basically ID is the ID of the DataBack item, and that's basically the domain, the zone name, but for syntactical reasons it doesn't have a dot and an underscore instead. So we'll repeat the actual domain name, which should be called zone name to be precise, but who is always that precise? And if we simply ignore the auto-populate field here, all we get here is a list of resource records, DNS resource records. So here we have our NS servers, our actual name servers. Here we have our A records, and further down below there'll be C name records and other stuff. So that's much more concise than the resource that I had been using for testing purposes. And what I'd like to build today is a recipe that can parse this DataBack item and define a zone for it. So, how does this work? Well, we need a new recipe, that's for sure. And I need to concentrate on using the right vim commands. So what do we call it? Well, of course, we'll call it recipes databack.rb. And what this will do is, let's first sketch it out. It's going to search the DNS DataBack for every item. Chef uses Apache Solr as its search engine, and that's basically a wildcard in Solr syntax. So give me all DataBack items that you have in your DNS DataBack, and I'd like to have this flexible. So I'll probably create an attribute for that, a node attribute. So I think that's our first change to the attribute file here, and I'll define, oops, let's do, and then I'll name this DataBack, and by default we'll call it DNS, but we'll be able to change it via this attribute. And let's go back to our recipe. So we'll use node cookbook, and I'll need to define this constant, and it's a DataBack. It'll return a string, and we need a symbol here, so we'll make it a symbol. Oh, well, I can simply remove the comment to have the syntax highlighting kick in, and that's that. And of course I need to store the result in a variable. Then I'll iterate over all these items. And what will we do now? We get back an item full of JSON stuff, well, basically a hash full of DNS records. And I'll go through all the different types of DNS records. So let's start with A and MX and CNAME, because they all might be in there. Access the key of this item. So if item, oops, what happened? If item key, if our DataBack item has a key for this type, then we'll go through all its records we expect it to be an array. Huh. Looks like we'll need another case statement. The chat's awfully quiet today, and I'm really not sure if my stream is simply not working or if no one's there, even though I have my dashboard tells me there are a few people. So why do you not just say hi in the chat and I'll see that I'm not talking to my monitor alone? That would help me greatly, so just give me a shout. Please. What I don't like at the moment is that I'd have to use different resources. So I'll have to check for the type A, I'll have to use the A record resource. No, I don't. It's no, it's just the DNS NSDX record. Item. Domain name. Then the type. Let's just use a counter. Because these record names need to be unique. So I'll simply use the name, which would be item host, I think. Let's take a look. Yeah, it's always host in this case. And I hope when I designed this years ago, I was actually using host everywhere. Yep. And then depending on what we have, we need more things, but I think I can blindly try and simply get them out of the hash. In the worst case, I get nil values. So how would this look like? Name and zone and type are clear, and then we have different fields for IP address and stuff. Okay. So name, zone would be item domain. Type would be type, but uppercase. What's the Ruby function for uppercase again? Stack Overflow to the rescue upcase. Okay. And then we might have an IP address. Maybe we should use something like that was not what I was hoping for. Yeah, that's tricky. Let's try another split here. No? Well, then let's do it without a split. I'll have to look up my key bindings in VI. Hi, Demon521. How you doing? Nice to have you on the stream. Okie doke. Here the field what we're looking for is IPv4. And let's take a look at the MX records. If there are any, there aren't any, so it's the C name for the C names. Okay, so IP address is item IPv4. C name is item C name. And that should be it. Something like this. We'll have to add the MX stuff later, but that should basically work. One thing I didn't explain at the start was that I also have a little file with helper functions. It's really just a few basic things, especially here the NSD zone dir helper that makes it easier to use the path to get the path to the zone files directory easily without repeating this everywhere we need it. Yes, it is. It's Ruby. To be precise, it's Chef. Chef is a configuration management software that we use to run our hosting infrastructure, and I'm in the process of building a Chef cookbook that sets up DNS servers. And the main thing this cookbook does is take DNS data and convert it into configuration files for the NSD DNS server. So, seeing that I have this cookbook constant littered all over the place, it might actually be a good idea to make this a helper. So I could simply define a helper named cookbook name, CB name, something more short. And return the cookbook name, and that should take care of repeating it everywhere. We could even actually use the constant here and never use it again. So, for example, in the master recipe, we've used this constant. And since we already include the helpers module here, I should be able to get rid of cookbook, replace it with cookbook underscore name, and we should still have a working recipe. Let's go and try in our test environment. It converged, so it seemed to be working, but let's try and verify, run our integration tests. Well, yeah. If you know the basics of JavaScript, how can you increase your JavaScript skills? I'd be the wrong person to ask, because I have not nearly a basic grasp of JavaScript. But the general answer would be do more, basically. Practice, yeah. Do projects, get a pet project to build for yourself, something that doesn't aim too high but still is a kind of a challenge, and start working on it. That's the best way to learn. While you're doing that, you can still look at things that other people have built, and ask yourself, why did they choose this option? Why did they do it this way? So you'll have a practical approach. I wouldn't recommend starting with something like reading books. But apart from live streams like mine, which doesn't quite meet your topic here, there should be things like screencasts or stuff that you can consume too, but nothing beats practice. Because that's the only place where you'll encounter the questions instead of the answers. Things like, why doesn't it work? I think that's the perfect solution I have here, and it still doesn't work. It sounded so logical when I read about it, or when that person presented it on their screencast, and now it doesn't work, and you'll have to fight through it and find out what you did differently or why it doesn't work in your case, and that's how you learn. I had that situation so many times myself, where the stuff that I read, and I read a lot of things, and I'm still reading a lot of things, just didn't survive colliding with reality. And it all seemed so logical, and then it turned out I hadn't understood a single thing. and I had to do trial and error or ask another person to find out what I was doing wrong, and then I knew how to do it. Okie dokie, let's get back to our current issue at hand, which is the DataBack recipe. I think that's basically something that could work, and I'm pretty sure it doesn't, but we'll only find out if we test it. So what I'm going to do is write another. No, I'll simply add the DataBack recipe to my test suite, which is in this file here, kitchen.docken.yaml, and I'll run the test recipe, and I'll run the nsdx DataBack recipe. So what I'll do is rename my zone file in something different. Let's call naming things. How are we going to name this zone? I don't want to use example.com because I already used that in the test recipe. So let's call it foo.com. Why not? And so we can strip down where is my JSON file? I have too many files open. Here. Let's quit it. Open foo. So we'll give it the ID foo_com, the domain name. Well, domain name foo.com. Well, why not type a dot when I mean a dot? We can use the DNS servers provided by our fictitious example.com here, but we'll simply strip down the number of host entries. We don't need hundreds of them. And apparently we have hundreds of them. We'll keep 2. A record www IP address 1234. We'll even leave the TTL in, and then we can add an A record for mail 2345. Delete all these C names. Lots of C names. Dear me. That's a lot of C names we've accumulated over time. that's actually the motivation behind another reason why I'm building this cookbook, because most of these DNS entries can be actually be derived from our infrastructure information that we already have in a chef server, and so we don't have to do this manually again and again. So let's create a web CNAME that actually points to www. Maybe I'll add another CNAME later. Here we have the MX records. I'll simply use one. Oh, we could actually keep the Google entries here. Doesn't really hurt, and it's a good use case. SPF records. And a test record, text record that simply contains a test. Test entry. Okay, that looks like a good example file. Let's remove a few spaces here. And now I'll create a test that, well, actually, if I've put this file into the right directory, the test should automatically have this DataBack item available, and the DataBack recipe should pick it up and do something with it. So let's see how that works. The first recipe will work, the other doesn't. And unexpected identifier, expecting string d-end. I have some kind of syntax error in there. No, I don't want the license file, I want the DataBack recipe. Something went wrong here. No, it didn't. Or did it? Oh, we don't have cookbook defined, so that's something I should do. Chef recipe. Use the include method to include our helpers, nsdx helpers. That will import the cookbook name method that we can use here. Oh no, it's not. How did that happen? That doesn't make any sense. Oh no, it does. Cookbook name DataBack to sim. Yeah, okay. Huh. It has some kind of strange syntax highlighting here, but I don't see. Where I'm actually breaking. Let's take another look. So the first thing that breaks is the counter thing. Syntax error, unexpected string, the end. It doesn't expect the string end. Why wouldn't it? Is it the plus plus? Okay. That's at least a different error. It says not found, so it didn't find any DNS data bag. And we have defined cookbook multiple times, which we probably shouldn't do. In zone registry we can remove the cookbook constant because it already gets defined by the helper. So we might be able to get rid of this helper method anyway by simply defining the constant. Let's see. Anyway, I think I didn't do what I said earlier, which is put it in at the right place. Test, I think it's... Wait a second, where is it anyway? It's in test DataBacks. I think it should be somewhere else. So let's take a look at our another. We could actually. Oh, I'm afraid I don't have kitchen cookbooks. No. Let's see. Test kitchen data bags. Okay, I might have to use the DataBack's path here. Test integration DataBacks. Yeah, looks like it. As soon as I define this, it might work. So, where's my kitchen file? DataBack's path is supposed to be test integration DataBacks. So it's not that I did put it into the wrong place, I simply have to tell kitchen where this place is. Still breaking. And still with the search. It does prepare DataBacks. Let's see if it works if I hard code the DataBack name, DNS. Let's close a few files. this one open. And still 404 not found. So test integration. It's not test integration DataBacks. Why doesn't it work? It's test DataBacks, right? Yeah, okay. Move test integration. No, move test DataBacks to test integration. Cookbooks should probably be under integration as well, but I'll not open that can of worms. Let's see. Huh. But did it run NSDX DataBack? Does not look like it. Oh, let's... At least it didn't do anything in this recipe, so let's do a bit of debugging output. Processing DataBack node cookbook name cookbook name DataBack. Oops. I'm not really good with my strings at the moment. Huh. This is already strange. Maybe I just had the wrong kind of coffee today, but it looks really strange. Unexpected string beginning. Well, that's all part of programming, isn't it? It seems to work if it's commented out. And oh yes, of course, there's the closing curly brace. Processing DataBack DNS. I just saw it scroll by, so that's working as intended. But now looking for type case records. We should also print out the zone we are processing. And it looks like we don't process anything. Found 0 zones. Oh, food.com isn't a DataBack file. Of course it should be foo_com.json. Huh? It's always the simple stuff. And of course, you check it last. Alright, so what did go wrong now? Something more interesting. It says internal server error. Probably because I actually don't know why. Where did it happen? It happens in the search. So we now have a DataBack item. We try to search and it bombs. Why does it do that? Am I using search wrong? Chef search. Oh, chef search is one of the Google queries that, well, meanwhile it yields the right results, but in the beginning this was a nightmare. Having an IT thing named with such a ambiguous name was a nightmare. So search. How do I search in a recipe? Query syntax, filter search results, search, the index, and then the query. So that should do it. Okay, so there's a parse error. It didn't make sense of this because I probably broke the JSON syntax, and yeah, that's syntax highlighting shows exactly where the problem is. Why doesn't JSON accept trailing commas? So annoying. 6. Okay. Found one zone, processing zone, looking for area records, nothing, MX records, nothing, CNAME records, nothing. Huh. Even though, oh, it's all suffixed by _RR for resource records. So that's where we have to fix our stuff. So we'll call it hash key. Type _RR and use hash key here. And then here. Okay. Property name must be one of string you passed nil. I can't do it this way. So we have to have guard clauses for this, I guess. That's ugly. But yeah, it's at least more defensive. Okay. Still. That's a bit more precise, does it? Oh, it's of course it's not item IPv4, it's record IPv4. And it's type uppercase, it's item domain, and it's record host. Still. Let's take a closer look. It's actually the name that doesn't work. Name record host. Adding entry and then, okay. Of course, yeah, the item host up there doesn't work. It's record host. But still. This is record. And each of these records is supposed to have a host entry, which it does. Okay, it looks different. Okay, now it doesn't work again. It seems to be the ++ actually that... Oops. Okay. Now record host doesn't work either. Local variable method record. That is strange. Okay. Maybe we have a naming collision here. Not sure. Let's use something different. Well, that certainly wouldn't work. And again, there's the issue with record host, which is nil. Let's take a look at this record. Footage record inspect. Okay, so we are actually, of course, so it does work for A and A records, but it doesn't work for MX records because MX records don't have a host field. Here it's called the subdomain. Okay. Oh, it's easy. And then preference. Let's look at the MX records. Subdomain distance is the name here, and MX. Okay. Record distance. Unless record distance is nil. Now this should work at least for A records, CNAME records, and MX records. Yep. But yeah, okay. The record name. Seems broken for some reason. Because it's item, no, it's item domain name. Does it? Output processing zone? Processing zone, okay, doesn't work either. Oh yeah, domain name. I think it's good to use a variable here. Item domain name. Okay, zone name. Okay, that looks better. So I get a zone entry foo.com.zone, but this zone file doesn't exist yet because in the end, after we have processed each zone, so we should probably rename this into zone item. Zone item. After we have defined all the records for a zone, we need to define the zone itself, which still is a zone name, and it has to have a contact, which is a zone item. No, it's actually not in the zone item, is it? Let's use host master at example.com for the time being, because we'll have to have, this should be either part of the zone data or a node attribute. Well, it probably should be both. So it should be zone item contact or node cookbook name zone contact, and then oops, we should have zone contact hostmaster at .com. And that should generate the actual zone file. And it does. And we have a few things. We have the www, we have the name record. It doesn't write the @ that we need here, and it doesn't write the actual MX. Yeah, that's because we don't pass it in. And web is defined as a CNAME for www. That looks good. It's not complete, but it looks good. So we need an MX, which is called MX, and in the record it's called MX as well, which is nice. Unless record, that's ugly, but maybe I'll find a better way to do this. Okay, let's take a look. Okay, now we have the MX, but it doesn't use this. MX has subdomain, but if that's empty, they should simply use @. Okay, that's nice. Didn't change anything, which it should have. And it still says NSDX record empty. That's strange. Okay. Just a second. Joys of a home office. It's supposed to have a name. Why doesn't it write the name? Let's try with a bit more logic. If type equals a, or lowercase a, entry name should be record. Well, let's do it the other way around. If we have an MX record, then the entry name should be the subdomain. Else, the entry name should be the host field. And entry name should be an @ if entry name is still empty. And then we should be able to use entry name here. I know it's ugly, and I'll have to find a better way, but I'd like to see if it works. And it does. Okay. Okay. That looks good. Now, since my time is running over, I'll do one final thing. And that is create a repository for this cookbook. Which will be called NSDX Cookbook under the FreeStyle organization. Chef Cookbook to set up the NSD DNS server, and I'll make it public. So that's that. So you can expect the code to show up, if not today, then tomorrow, because I'll have to extract it from our big Chef Cookbook repository, for which there is actually a good way to do this, and I'll try it out, and so there should be something to look at before the weekend. In any case, I'll end this stream now. I might be doing a bit more work on the cookbook, but that'll just be either cosmetic stuff or adding new record types to my business logic here. If you have any questions, you can tweet me or email me. If you have any feedback, if you like what I did, if you didn't like what I did, if you have suggestions what I could do, or what I could do better, then I'm always open for constructive feedback. Just tweet me or send me an email, and I'll be happy to read it.